Hey everybody, welcome back for another installment of the X231 Minneapolis-Moline prototype tractor restoration series. Today's video is going to be centered around getting axles and bowl gears in this rear case. I've got an axle shaft on the bench, bearings are pressed back on it, as well as the seal wear sleeve, and you'll notice it has the round keyway. So yes, I am going to reuse one of the original prototype axles in this thing. I really inspected this one very closely. The splines are still in good condition on this one, and they fit the bowl gears just excellent. So one of the two prototype axle shafts is going to get put back into X231. You'll find out just a bit later on in the video what I'm going to do about the other one that's too badly worn to be reused. I've also got the 10X prototype outer bearing housings all cleaned up, prepped, ready to go. We have some new axle seals here. I've got 4 of them. It's CR number 28687. The reason I have 4 axle seals is because the original axle seals, not only in X231 but in the production 445s, were a very wide double-lipped leather seal design. So I'll just double up these single-lipped rubber seals. I've got a few tricks for doing that. Quick specs on the CR 28687s. Like I say, they are the same for X231 and production 445. The specs are 2.875-inch shaft, seal outside diameters 3.751 with a 0.4375 width. So in case you're wondering, a national number 417344 would also be a direct stand-in for those. And I've also got some bolts cleaned up here. These are the bolts that hold the bearing housings onto the axle tubes. And all the original Minneapolis-Moline bolts were these Rockford grade 5s. And you know I'm a stickler for using the proper hardware, so every one of those is a Rockford grade 5 bolt. So before I can begin fitting this axle shaft in the housing, I first need to get the oil seals and the bearing races installed in these outer bearing housings here. The seals go in first because they are outboard of the races and they will not pass through them. That's one kind of inconvenient design Minneapolis-Moline had on these 445s and several of the subsequent tractor models that came after. To service any axle seal leaks, you had to take this entire housing out, tap this bearing race out, and then you could finally get at the seals. It was kind of a pain. That's just how they did it. So seal will go in first, and I'll make sure to note that the seal lip is pointing in. We'll start with the outer one, and I'm actually going to press it in using even steady pressure instead of driving it with a hammer. And I'm going to use this bearing race installer. I just have the disc set backwards on there so I can utilize the flat face of it. And I'll just use steady, even pressure with the hydraulic press to seat that seal all the way to the bottom of that housing. Now, starting this in straight is half the battle, and you do have to be very careful when using a hydraulic press because you don't have the same amount of feel as you do with an arbor style. There we go. Looks like it's starting in straight. Like I say, you definitely want to be careful because a hydraulic press has so much more pressure than an arbor. That seems good. You don't want to go too far and crush that seal. Okay, so that looks pretty good. The seal is fully bottomed in the bore, and you can see the seal lip just extends inside that external opening, so that's just going to be perfect. Next thing I want to do now, take some good bearing grease, and I will carefully manually pack the internal body of this seal full of grease. And in doing so, that is going to greatly extend the life of this outer seal because these modern rubber lip style seals are so much more effective than the earlier leather ones. If I put the other seal in on top of this, it will be so good at keeping the oil inside that this outer seal would likely run dry and would wear out in short order. So packing that with some grease is actually what's going to provide the lubrication for that lip to ride on the seal sleeve that's on the axle here and keep that thing working for a long, long time. So that wasn't such a problem on the earlier style leather seals because they would naturally seep oil anyway. So you'd always have some lubrication on the sealing surface. So packing that with grease, very important step. Now that that's done, I can press the inner seal in right on top of this using the same process. So now that I have a double lipped seal in there once again and everything is in place and looking good, the next step is to put the bearing race on top of those seals, and I turned out this disc on the lathe. I created this shoulder just in from the edge. It matches the upper portion of that bearing race and will act as a driver as I also push that down into place. So with all the seals and both races installed in the outer bearing housings, I can start fitting this axle into the case. I've got both of the inner races installed already, so we're good to go there. The way this is going to work is I'm going to place this axle into that rear end housing until this inner bearing comes up against the inner race. At that time, the outer bearing housing gets bolted on, and bearing preload is adjusted by stacks of these shims and paper gaskets. Basically, you want to have 30 to 130 inch-pounds rotational torque beyond however much rotational torque is created by the new seals on the axle. So there's going to be some trial and error assembly going on. Instead of messing with stacks of shims, I'm going to start with this single 50 thousandths thick gasket that I made. That's going to be my starting point. So I basically just have to put that together with this gasket in there and see where I'm at. So with the 50 thousandths gasket in place, everything's still just a little bit loose. I've got a good 9 thousandths in play and about 10 inch-pounds of drag being applied by the new seals on the shaft. So next step now, I'm going to take that 50 thousandths gasket out, and I've made a 30 thousandths one. That should more than take up for the end play and give me some preload. It's just a question of how much. Okay, old gasket out, new gasket in. Carefully avoid damaging the seals. Start it on the sleeve. Okay, we'll try this again. So that 30 thousandths gasket under here put me right where I want to be, no more in play. And we've got a little bit of breakaway torque and about 50 inch-pounds of preload on this shaft, right where I wanted to be. And I don't have to mess with any of those steel shims. I have a single good gasket under here that I know is going to seal, so pretty happy with it. My setup is done for that side. This other axle is not going to be quite so straightforward. If you remember back to the axles, bull gears, and problems video, this splined end is worn way too badly to ever have a bull gear tighten up on it again. But if you'll follow me out to that other shop, I'll show you what I'm going to do about it. So what I decided was the best way forward for me at this point is to mill down one of my good production 445 tractor axles to match the dimensions, bearing surface wise, of the original prototype. And it's also the route that most of the viewers on here recommended I take too. That did make this decision a bit easier. Guys, as always, I thank you for your input. What I do like about going this route is I trust the metallurgy in this axle. I trust the strength of it, and I know it is every bit as good, if not better, than the original prototype one that I'm replacing. The part that I don't like about it is I'm going to have to contend with this having a square cut keyway, whereas the other prototype shaft that I am reusing still has the round. They're not going to match, but at the end of the day, it is what it is. It's just reality at this point. So for this job, we're going to use the old Shepherd lathe, and this thing is old. It's probably the oldest piece of anything we have on the place, and I'm talking like dawn of the 1900s here. But it still does a good job. We have the axle set up in it on a live center on each end, and we also did have to go to using the steady rest. If you remember back from the last video, we tried a couple passes here and it was chattering. We didn't have a rigid enough setup without the support that the steady rest adds. Due to space constraints, we tried it without it on there because the only place we have for it is that old machine bearing surface, and that puts us very close to where our cutter has to be. But you obviously can't run a steady rest over a keyway, and you cannot run one on a non-machine surface, so that was really our only option. But Now that we've redone our tool post, got the steady rest on there, we did another pass. It's cutting well now. So now that we have all the problems sorted out, let's make some chips. So we did as much machining as we could do, and we're within probably 8/1000ths of what the desired finish diameter is, and we're going to finish it the rest of the way off with the tool post grinder. That gives us the best finish to press a bearing on. You can see we've got the stone dresser kind of set up in here. We just left it in place so that we can redress if needed, and plenty of rags covering the ways and all the mechanisms to keep that abrasive grit out of the lathe and reduce the overall wear factor. Just doing a final measurement now, and it's good. I like that. We're done. So a quick rundown of what just happened. I've got the old prototype shaft that I cannot use here, and we have the newly machined production shaft, which has been made to match where the bearing locations are on the old prototype one. Basically, we just mimicked what they did here. You can see they had like a rough cleanup pass right here that we also did right there, just to round things out. And then we took what used to be the unfinished portion that extended out to about here and cut that all the way down. I'll give you a diagram. We took that old unfinished portion and took that down to 2.503 inches diameter. That's where the bearing and the seal sleeve is going to be a press fit. So then what used to be the 2.503 diameter out here on the production axle, we reduced that to the 2.495. That is basically the usable hub surface that extends on out to the end. So we just we did everything the same as this. It's hard to see where we stepped from 2.495 to the 2.503. About all you can tell here is about right here. You get a variation in the color. We're a little duller out here. We polished it a little more here for the press surface, but it basically mimics this. It's a little bit easier to see the step on the old prototype axle where we go from the hub surface onto the press surface. About the only other thing I could do, but probably won't, is extend this square 3/4 inch drive keyway back as far as the round cut keyway went on the prototype shaft. It's really not worth it, because once you get the bearing and then the seal wear sleeve and then the outer bearing housing on, you're really not going to gain any kind of hub travel by cutting this keyway back so that it goes back underneath the wear sleeve like it was on the prototype axle. So I'm going to call this one good. We're ready to press the bearings and the wear sleeve on. It's getting late. I need to take this to work anyway, because that's the only place I have a press tall enough to press those bearings on. So we'll come back to this tomorrow, hopefully get this axle put in. So long story short, these bearings went on well. I'm very happy with the press fit, and I'm going to start fitting this axle into this side of the case. It's the same procedure that I did on the other side, so you really don't need to see that again. And finally, I've got 2 axles installed and preloaded in this thing. On any other tractor, this would have been a 3-minute video, 4 tops. But like I said before, X231 just doesn't ever give you anything at all. You got to work for every bit of it. But man, that thing got wide. Look at that. It's been so long since there's been anything in this case, I forgot what it looks like to have axles in it. All in all, that production one ended up fitting pretty well. I guess I'm about as happy with it as I can be. So I'm going to wrap this installment up right here, but in the next one, I'll be pulling these axles out again. Yes, they need to come out one more time. Now that I've got my preloads figured out, I can pack these outer bearings with grease. I can start fitting bowl gears. I can get lock washers under these bolts. Just start making all these assemblies more permanent. So guys, as always, I thank you for watching, and I hope to see you again.